Alright, this is part 2 of a test that's all about radical functions. In this video we will focus on graphing radical equations such as these. We are going to do this without using TI-30XS multiview, which you could just type the whole thing into the table and it would just do it all for you. But you are allowed to use a 4-function calculator. So you may see me use this calculator, but when I do, I will be pretending that all I can do is add, subtract, multiply, and divide. Okay, number 8. We will start by looking at the parent function, square root of x. So we will pick x values that are easy to take the square root of, like 0, 1, 4, and 9. Okay, so to get the y values, we will go ahead and take the square root of these x values, and that will give us 0, 1, 2, and 3. Now, is this a function where we need a third column? Yes, we will do a third column anytime you have an a value here in the front like this. Okay, this -2. So let's go ahead and put a third column on this thing. The third column is our a times y column. So we will take this -2, which is our a value, and we will multiply it times all the y values. So that's going to give us 0 and -2 and -4 and -6. Now once we have this new y column, the ay column, we can forget about the old column. So this one is out of the picture. So we can now go ahead and graph these points, 0, 0, 1, -2, etc. So this will not be the final answer, so do not connect these dots, but 0, 0, 1, -2, 4, -4, and 9, -6. 9, -6. Okay, so you can see the transformation that has happened. We have reflected over the we've reflected over the x-axis so far, and that looks like a vertical stretch. Anyway, the one thing that we haven't done yet is we haven't dealt with these two transformations. So the +2 right here, what that's doing is that is going to shift everything to the left by 2. Okay, whatever's going on under the radical here is a horizontal motion, but it's the opposite of what you would normally think. So +2 will actually take us left 2. Now this -4 right here, this is always a vertical motion, and it's normal. So this will take us down 4, just like you would think. So left 2, down 4. So if I take all of these initial points and move them left 2, down 4, I will get my final answer. So left 2, down 4. And left 2, down 4. And left 2, down 4. And left 2, down 4. Okay, so the graph begins here. You know that we see that in the normal parent function, we always start from 0, 0, and then we go. Okay, so the original graph was starting at 0, 0 and moving to the down and to the right. So this was the original point. So I know I'm going to start here, and oh man. So this is what your graph should look like with an arrow on this side. Now I think we're being asked for the domain and range. The domain is the x values. So the x values go from -2 to infinity. And we will use a bracket on the -2. So -2 to infinity are the x values. The range is the y values. Alright, and we have to go from bottom to top. So at the bottom, it goes to -infinity. And then at the highest point reached is -4. So it goes from -infinity to -4. And we'll put a bracket on that because it reaches -4, it touches it, so we're including it. And that is it for problem number 8. That's how you graph a radical function. Now on number 9, notice that it is a cube root. So we will be looking at the parent function, which is the cube root of x. So we will start by picking values for which it will be easy to take the cube root. For example, 0 works well. The cube root of 0 is 0. 1 works well because the cube root of 1 is 1. But after that, we have to jump all the way to 8 is the next thing that has a nice perfect cube. Alright, because the cube root of 8 is 2. But we can also do negative numbers. So -1 and -8 will also work well. And so if we take the cube root of these x values to find the y values, we will have -2, -1, 0, 1, and 2. Now, is this a problem where we need a third column? Yes, we have an a value of 1/2. So that means we're going to need a third column for the a times y. Alright, so this will be our a times y column. And in this column, we will take this a value of 1/2 and we will multiply times all the y values. Okay, so we're going to take half of each of these things. So half of -2 is -1. Alright, half of -1 is -1/2. Half of 0 is 0. Okay, and then we've got 1/2 and 1. Alright, notice we do not need a calculator for this at all. Alright, once we have the third column, we can forget about the middle column. Okay, so let's graph these points. So -8, -1, and right now we will just do the skeleton. So -8, -1 would be right here. -1 and -1/2. Okay, and then we have 0, 0, 1 and 1/2, and 8, 1. Okay, so this is what we have so far. Alright, so far, we've done the a value, so we've done the vertical compression by a factor of 1/2. That's why it's so small. But what we haven't done is we haven't done the shifting yet. So this -3 right here is going to give us a shift to the right 3. And this -5 right here is going to send us down 5. So everything's got to go right 3, down 5. So we will do that. Let's take each one of these points and go right 3, down 5. Okay. 3 to the right. 1, 2, 3, 4, 5. Come on. Okay, this is going to be a little bit off the charts, but that's okay. 1, 2, 3, 4. It'll be about right there. Okay, so this will be the final graph, so we just need to draw a curve through this. So your graph should look like this. Now the domain and the range are very easy, the domain being the x values, but the x values go left and right forever, so that's negative infinity to positive infinity. Alright, the range is the y values, but it goes down forever and it goes up forever. So that's again negative infinity to positive infinity. Alright, so that is it for problem number 9. Alright, for number 10 we're back to square root again, so we will be dealing with the parent function square root of x. So that sends us back to good old 0, 1, 4, and 9 for good values to use. And we will go ahead and do the square root of these x values, which will be 0, 1, 2, and 3. Let's go ahead and graph this. Oh, wait. Do we need a third column? Yes, we do. There's an a value, and whenever there's an a value here in the front, we will make a third column to accommodate it. Okay, so in the third column, we will do a times y. The a value is 2, so we will take 2 and multiply it by all the y values. So that will give us 0 and 2 and 4 and 6. Alright, once we have this third column, we can forget about the second column and use this instead. So as we plot these points, this is the skeleton, not the final answer, so do not connect them. So we are plotting 0, 0, and 1, 2, and 4, 4, and 9, 6. Okay, so that takes care of the vertical stretch, but what we haven't done yet is this shift. So this -1 tells us that we need to move to the right. Whoa. We need to move to the right by 1. Okay, so let's take each of these points and move them to the right 1. Okay, so this is our true graph right here. Alright, so your final graph should look like that. Now, let's talk domain and range. For the domain is the x values, which go from 1 to infinity. So the domain will be from 1 to infinity, like this, with a bracket, because it touches 1, 1 is included. Now the range, that's the y values. The y values, the lowest y values here at 0, because it's on the axis. So 0 to infinity. Would be the range. Alright, so that is it for problem number 10. Alright, for number 11, we are back to cube root again. So we will go back to thinking about the parent function cube root of x. So the values that are easy to take a cube root of are -8, -1, 0, 1, and 8. So for the y column, we will go ahead and take the cube root of these x's. So that will be -2, -1, 0, 1, and 2. Do we need a third column? No, there is no a value, so we don't need a third column this time. So great. So let's go ahead and graph these, the parent function. So -8, -2, and -1, -1, 0, 0, 1, 1, and 8, 2. Alright, we'll leave that as the skeleton. Now, the thing we have not done yet is the shifting. So the -2 will send us to the right by 2. and the positive 5 will send us, why did I almost say down? That was silly. Alright, out here it works like normal. So positive 5 will send us up 5. Okay, so right 2, up 5. So let's take each one of these points and move them right 2 and up 5. Okay, right 2, 3, 4, 5. Alright, I see kind of the pattern here, so I'll go ahead and do that. And then, okay, one more time, right 2, and 1, 2, 3, 4, 5. Okay, so now we just have to draw our curve through here. Okay, so your final graph should look like this. Now, the domain and range of all cube root functions will be the same, negative infinity to positive infinity for both domain and the range. Alright, the reason being, domain is the x values, and the x values go to the left forever and to the right forever. The range is the y values, which go down forever and up forever. So that is it for problem number 11. Alright, this is a good place to stop this video because that completes the graphing portion of the lesson. In our next video, we will go on to talk about transformations, and we'll be making up functions that have certain transformations, reflections and shifts and stretches and compressions, and things like that. But that'll be for the next video. So go look for part 3. I'll meet you there.